Hello guys, how are you doing? It's me. Okay, I can see myself. Can you all hear me well? How was today's contest, guys? It's me. WTF was B. Interesting. And guys, let me tell you at the beginning, as you might know, tomorrow is the first contest of Repovive, and there is $500 in prizes in the contest. We are doing it to make the community more engaging and make a situation that everyone can grow. And how many of you are in the boot camps, in the free boot camps that we have? How many of you participate in the boot camp? Just so you know that, so I know that which ones of you are already there. Plus, plus, plus. Okay, great, great. If you're not familiar with the bootcamp, we have a free Codeforces sub expert rating level up bootcamps where I teach everything you need to reach experts. I add all the problems here, and you can, whenever you accepted the problem, you can just check that and you can ask all your questions here and I will respond. Yesterday it was late night when tonight or your tomorrow morning we're gonna have the next session, the fourth session of the camp. If you are interested, you can join in here. And let me also bring the ones who are watching from the website. So if you guys are ready, we can start talking about the problems without any further ado. Cooked, couldn't implement C. You guys are look angry after the contest. Hardest if to ever. Let's see what people on the website are saying. Why no one is on the website? Guys, if you are watching from YouTube, it's better if you watch from the websites. I mean, we should implement more features in the website, including voice, so that you can talk with your voice. For now, it doesn't have enough features. When we have time, we implement more features there. But anyway, you guys are very angry today. Salam, Aran. Okay, then let's go over the problems. I read the problems very quickly just before starting the stream. I honestly delayed the stream for 5 minutes because I wanted to read quickly the problem B and C as well. And we're gonna discuss the solutions. I mean, I'm gonna tell you the things that, the solution that I have. And we definitely, it's a discussion. It's a solution discussion stream. So we're gonna discuss together to solve the problems. Hopefully, I estimate that we probably can solve A to D. I haven't read D yet, but we're gonna discuss it together. And we're gonna talk about the solution. Okay. If you are ready to start, yeah. Yeah, I see. Many people are mad at it. What even was B? We're gonna talk about it. We're gonna talk about the solution. If you're ready, put a plus or use this emoji if you're in YouTube. If it was anyone's first time, then they will never comment. That's bad to hear, if that's the case. She only acts in 30 minutes. B was so hard. And thank you guys for the hearts. It means so much. Okay, let's go. So he seemed easier to me. Just yeah. We will talk about all this. Let's start talking about the problem. So the first problem, so lucky with Kalamaki, it says that we have two players who are playing. There are n minus one rounds. In each round, a player, so lucky plays on odd rounds. Kalamaki plays on even numbered rounds. And each player, when plays on round I, can swap AI and AI plus one. And Sulaki means if and only if at the end the array A is sorted in non-decreasing order, he can also at the beginning change the order so that he can guarantee his winning. You have to say that if he can change the order in a way that he will guarantee his winning or not. Can he do that or not? I said the statement very quickly because I know that people who are in the stream already know this. What is this statement? So let's talk about it. So the first thing that we can say in here, guys, is that what's the most sane thing that Souvlaki can do at the beginning? You tell me. When he rearranges the array at the beginning, what is the most sane thing that he can do? I'm so mad at myself. I was not solve a single problem. Oh, I will tell B. Definitely. Took too much time solving A. Initially make array sorted. That's a great idea. Great idea, sorts. Yes. The most sane thing that he can do at the beginning is to just sort the array. And once he sorts the array, just play the game. When we sort the array, definitely Souvlaki has a very clear way of playing. Kalamaki has a very clear way of playing as well. Souvlaki, when he has two numbers, he will always change them. If it's an inversion, the number before is greater than the number after. Or Kalamaki does it vice versa. If the number after is greater, he will swap them. And Souvlaki will lose if in one of the moves of Kalamaki, these two numbers are not equal. If they're not equal, Kalamaki can play in a way that the smaller value comes here, and then Souvlaki can do nothing about it. So the solution is simple. Just sort it. For example, for this one, just sort it. It's 1, 3, 2, 3, 5. So if we sort it, it's going to be 1, 2, 3, 3, 5. Then we play it again. First, Souvlaki definitely does not rearrange these two. Kalamaki will swap these two. We'll make it 3 and we'll make these 2. And then from here, Souvlaki is going to lose. There's no way he can win. Because 3 is there and he cannot change it anymore. 3 is before 2. So the answer is no. On the other hand, for this one, if we sort it, we have 1, 1, 1, 5, 5. If you start from the beginning, these two won't be changed, these two won't be changed. They're equal. These two won't be changed by Souvlaki, these two won't change by Kalamaki as well because they're equal. So the answer to this one is yes. So you just sort it, and for all these positions, compare the second one and the third one, fourth one and the fifth one, sixth one and the seventh one. And for each two, if they're not equal, Kalamaki can make the bigger one before the smaller one, and then he will win, and Salamaki will lose. That's all. Sort it and just play the game. And you know that how Kalamaki plays, how Souvlaki plays. It's very easy. And then at the end, see that who wins. That's all. If it's clear, please put a plus or use this emoji and put a plus here. If we haven't added reaction in here, that's in our list. Although we have especially some things that you will see. We are working on a few things that you will see, but that's one of the things that we are planning to do. I misread the problem. Oh, I see. That's really bad. Doesn't get repeated numbers. Yeah, exactly. Proceed with people. Sure. Thank you, Manas. Great. Why do they fray? I don't know. Maybe it wasn't very clear. I don't know. Can you explain this one more time? Yes. We say that at the beginning. So lucky, the most sane thing that you can do is to just sort the numbers in increasing order. Just sort the numbers in increasing order, and then just play the game and see that who will win at the end. Hi. That's it. No, just sort the numbers and play the game and see that who will win at the end. Okay. Is it clear now? If it's clear, we can proceed to B. Okay. Okay, I guess we should proceed to B. We are doing the camps, the boot camp, the free boot camps, and we are doing it for now for everyone who is below experts rating to level up. We have the fourth session today, and all the videos of the previous sessions are here. The third one is not here yet. I will add it just after the I can add it during the solution discussion as well. And all the problems are here as well. The problems that you saw. These are the best handpicked problems that are chosen from many problems. And if you want, you can easily just register in here. There's a button that you can register it if you want. But we will do topic streams there as well. We will have topic-based bootcamps as well. Let's move on to problem B without wasting more time. So this problem says that you are given a permutation P of every integer from 1 to n. You also own a binary string S of size n where Si is 0 for all I from 1 to n. You may do the following operation at most 5 times. You can choose to L and R and every index that is between L and R. And its value is between minimum of these two endpoints and maximum of these two endpoints. You will set that Si to 1. You are given a binary string X of size n. You need to make sure that wherever Xi is 1, Si is 1. You have to figure out any sequence of at most 5 operations such that the aforementioned condition is satisfied, or report that it is impossible to do so. Note that you do not have to minimize the number of operations you make. So this is what the problem says. I said it very quickly because, again, I'm assuming that you participated in the contest. And if you are pupil, the camp can be very useful for you. I mean, that's actually for people around the expert. If you said it regarding the camp, that's for you guys, exactly. Could not solve. Yes, I will tell you about it. I will tell you that the solution that came to my mind, I didn't think about it for long too, but I think I have a solution, and I will tell you. And if you guys can discuss on it as well. Guys, the idea that came to my mind when I looked at this problem, I was like, okay, wherever we have one, we still have this from yesterday's camp. Wherever we have one, there should be some L and R such that L is before it, R is after it, and this one is, these two values are in a way that it will be, this value in this index will be between these two. Wherever we have one, there should be such L and R. So the first thing that I said that, okay, between all the ones, we have many ones. So between all the ones, let's consider the leftmost one. First of all, the first thing that came to my mind, let me first say the first thing. The first thing that came to my mind was that if we have a 1 at position 1 or have a 1 at position n, it's impossible. Also, if the value of an index is 1 or n and we have 1 there, that's also impossible. So these cases are impossible first. Do you guys agree with this? This is the first thing that's probably it came to your mind too after reading the problem. Is it clear? Do you guys agree with it so far? So I'm just saying a very trivial thing. That's, I know that most of you have thought about this too. And then I will say that we have several ones. Okay, when we have several ones and we know that for each of them something should happen, one thing that we can do is to consider the leftmost one of them, for example. Let's just start with it and see that what do we get. Let's consider the leftmost one that we have. We should definitely, one of our operations should be in a way that we will choose something from the left of it and something from the right of it, such that one of them, either the one to the left is less than this value. For example, assume that here we have x. Either this part is less, the value we choose this way is less than x, this way is greater than x, or vice versa. This is greater than x, this is less than x. One of these two should happen. But the key point is that because I chose the leftmost one, none of the previous ones need to get 1. None of the previous ones need to turn into 1. So I'm not worried about them. This is the leftmost index that should turn to 1. So the previous ones are not important. I'm not worried about them. Do you agree that? First, let's consider about this choice. If the left one should be less than x, will be less than x, and the right one is greater than x. First, let's talk about this. Do you agree that the most optimal thing is that if I choose the one less than x leftmost possible and the one greater than x rightmost possible to turn the most things into one that I can do? I should turn this index to 1. I should choose something to the left of it, something to the right of it. First, assume that to the left we want something smaller, to the right we want something bigger. Do you agree that the one to the left is better to put it as left as possible? The one to the right is the best to put it as right as possible. Also, in the other case, if this is greater than x, this is less than x. It's the best to choose the one that is greater than x as left as possible, the one that is less than x as right as possible. Do you agree with this so far? If you agree with this, please put a plus or use emojis. Yes, you will choose the maximal range. Okay, now I say that because we don't have any limits for the values before this. This was the leftmost one. This is the leftmost one. So before that, nothing is actually important. No one needs to be 1. So actually to the left, it's not really important to choose the leftmost one because these values are not important. They are 0 and they're happy with being 0. It's not necessary for us to turn them into 1. So the only limit is to choose the right one as right as possible. So we have two choices. Either we choose something less than x and something greater than x here, or something greater than x and less than x in here. So we have two choices. Between these two choices, which one we choose? The one that if we take a look at the right, it gives us the rightmost choice. This is a greedy way of thinking. I say that, okay, left is not important because this was the leftmost thing that should turn into 1. So I do not care that which one is this, really. Between these two cases, I choose the one. I do not worry about the left part because they are 0 and they're happy with being 0. To the right, I want to choose something that goes maximum possible. So if I had two choices, maybe I have one choice. Maybe, for example, after this, we have only things that are less than x. But if I had two choices, I will choose something afterwards that goes to the most right. And this is the best operation that I can do for this one. This is optimal, so I will do this operation. My greedy, I have a proof for my greedy. I say that if I had any other solution that makes this into 1, consider the range that makes this into 1. Instead of whatever you chose, choose this range instead. It gives you the same answer. This one works as well. Do you guys agree with this? If you agree, please put a plus or use this emoji. If you don't, put a minus or let me know. Great. Problem B. It's problem B right now. If you guys agree with this, please put a plus. Otherwise, put a minus. So I guess it's clear, right? You can also use this emoji. Okay, so I will repeat it. What I'm saying is that we have several ones. Among all the ones, choose the leftmost one. We know that we need to cover this at some point. So consider the range that covers this. Either to the left we choose something smaller and to the right we choose something bigger, or vice versa. To the left we choose something bigger and to the right we choose something smaller. I say that in both cases it's the best to put the one to the left as possible, the one to the right as possible. Okay. But then I say that, wait a minute. Actually, to the left is not that important. I don't care about how left we go to the left of us because this is the leftmost one. The ones to the left of us do not matter. So my only condition is that to the right, I should choose it as right as possible. That's what I need to make sure. Is it clear? Yes, for two cases, I would choose the right ones. I don't know actually how to run dry run on that. Take a look at this statement. Have you read this statement? Probably it's best if you read this statement first. If you haven't. This statement just says that we want to choose some L and R such that I is between L and R, minimum of PL and PR is less than PI, less than maximum of PL and PR. And then we can turn those things into one. And now we say that, okay, among all of them, choose the leftmost thing that is one. Less about that, just we know that the operation that will cover this, in that operation, for the left ones, we will choose it as left as possible. For the right one, we will choose it as right as possible. And we know that by doing this, this is gonna give us an optimal answer if we choose the leftmost one as left as possible and rightmost one as right as possible. And then we say that we chose the leftmost one. So the ones that are to the left of it do not actually matter. So to the left, we don't care about it. We just want the right to be as right as possible. Okay. And then I say that, okay, choose the choice that gives you the rightmost possible choice for the right. And then this will cover some of this. This will turn some of these into one. And then keep repeating this operation. Keep repeating this operation. Again, choose the leftmost one that is not satisfied. Next time, again, choose the leftmost one that is not satisfied. Again, we can know that anything to the left of it does not need any operation. So we do not care about them. An operation now should cover this one. And since an operation should cover this one, we know that to the left of it, we have to choose one of these. And we know that to the left of it, we don't care. Again, we will choose the range that it covers maximum possible to the right. And we will continue doing this. If in 5 operations we can cover all of them, it's good. Otherwise, it's not possible. Is it clear? And do you agree with this solution? Because as I said, it's a solution that came to my mind by just reading the problem a few minutes after the stream. So there's also a possibility that there are issues with the solution. So let me know. I mean, let's discuss it. I mean, if it's not, tell me if you have solved it with the same solution or you have done other things. And then I make sure that you all understand it. Yeah, first, I will ensure that all of you will understand it. First, let's just see if you guys agree. Guys, I just want the feedback from you. Which one of you have understood it so far? Which one of you don't understood it? Well, you choose LR, which gives max range. Because I chose the leftmost one, and I tried to cover the leftmost one. Yeah, I will show you an example. I will choose the leftmost one. Okay. So everything that is to the left of it does not matter. So I do not really need to turn them into 1. They do not care. They are 0 and they need to be 0. They are okay with being 0. So I just need to maximize the value that I have to the right. Right? Let me ask you a question from the ones of you who have solved this problem, who have accepted this. Did you guys use the same solution or something else? I want to get some. First, discuss it a little bit, and then I explain it on an example as well. I know that I know that some of you didn't understand the solution yet. I will repeat it, and I will show you on an example. Position 1. So maximize in the sense that rightmost. Yes. How not thinking about leftmost value help us? Because finding rightmost value is equally complex as leftmost value. I will talk about that one second. Okay. So just as a feedback to understand that's what is your situation. If you understood it, please put a plus. If you didn't understood it, please put a minus. I want to have an understanding of how much you understood it. I mean, how many of you understood it or not. Yeah, I mean that's totally okay. I agree that it is kind of overwhelming. I agree, and I will explain it once again. Minus 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 plus minus minus. So if at least we have some plus, it means that the solution is correct. How to solve first one? I talked about the first one too before it. You can watch it here. Okay, so I think that the solution is verified. I just make sure to tell it to you in a way that everyone understands. And after that, we will look at the solutions of some other people to see that if there are other solutions for the problem as well or not. Yeah, I mean, I want to tell you an example. Let's move on an example and let's talk about it. So let me see that which one of these. None of these actually look like a good example. Let me see if I can create a better example. Guys, let's consider that this one is 0 and we are solving this example. Let's see what it happens. We have several ones. We need to turn them, it means that in S, we need to turn them into 1. So, for each one of these ones, I should choose an operation that I choose something from the left and something from the right, and one of them is smaller, one of them is larger, and that operation makes this into 1, right? What I say is that let's consider among all these ones, let's choose the leftmost one of it. Let's choose this one. Do you agree that I should definitely choose something from the left of it and choose something from the right of it, so that from the left we have something, either to the left we have less than it, to the right we have greater than it, or from the left we have greater than it, to the right we have less than it. We should have one of these two choices, right? And other than this, we say that if we fix, for example, assume that I want to choose something that is less than it to the left of it and something greater than it to the right of it. I say that because definitely it's optimal for us to choose the index that we choose for R. We should choose something for L, something for R. AL should be less than X. I'm considering the case that AL is less than X, AR is greater than X. There's also a case where AL is greater than X, AR is less than X. Okay, let me take a look at I will answer your questions. Let me show it on this example. So to the left, I should choose something like AL that is less than X, and to the right, we have AR that is greater than X. There is also another case where AL is greater than X, AL is greater than X, AR is less than X. So let's consider this case first. Do you agree that I will choose the R that is maximum? That is maximum to the right. Why? Because if I choose something that is as right as possible, it turns most of these into one. Because L is here, if I choose R to be as right as possible, it turns more values into one. Do you agree with this so far? Is it completely clear? If this part is completely clear, then we can talk about the next part, and the next part can be way simpler. Do you agree that if I want to turn this value into one, I should choose something from its left, something from its right, and one of it should be less, one of it should be greater, and for the one that is to the right, it's the best to choose it as right as possible because it turns more values into one. I'm saying that assume that we have several choices for the right one. Among them, the best one of it is the one that is as right as possible. Great. I want to explain to make sure that all of you understand. For the one to the right, it's best to choose. We are not choosing. I'm just saying that consider all the choices that I have. I'm just saying a theoretical fact. Okay, we are just talking about a fact. I'm saying that among the ones that are to the right, the best one is the one that is as right as possible. It's just look at it as a theoretical fact. Assume that we have several choices, we have some choices. Among them is the best one. I'm not saying that how to find that R for now. I'm not saying among them is the rightmost one. Is it completely clear? So R should be maximum, R itself, because it turns more values into one. Awesome. Yes, I'm saying choose rightmost element greater than X. If to the right you want to choose something greater and to the left you choose something smaller. And if to the left you want to choose something greater and to the right you want to choose something smaller, also you have to choose the rightmost thing that is less than this. Because you are saying that why we don't choose the one that is largest right to it. Because being larger, yes, that's actually a right thing. I mean, that's actually something that is also important. Let's take a look at the codes of some people. Maybe if I show the code of some people, it would be better, and maybe we understand simpler solutions too. Yeah, because you're right. I mean, I totally agree with what you said. Let's. It seems like there are easier solutions, and let's see what does this guy say. Let's let's see that what other solutions we have. Also, guys, if you have any solution, feel free to share it. Oh, yeah. Yes, that's actually a great thing to us. Yeah, I mean, I agree. I agree with that. Yeah, I think maybe this solution that I have is a bit problematic because if we have to fix it, it's gonna be very complicated. I believe that there should be some simpler solutions because it's problem B actually. So yes, I mean, if you take a look at this is actually a very simpler solution and it's way better. So let's just talk about this solution. This is actually a way better solution. It's very interesting and beautiful. I mean, this is actually beautiful. So, what does he say? He says that let's first, guys. Let me tell you the solution that this code is doing. This solution, guys, says that first we do anything from 1 to index of 1. We have to actually say that he's actually, I mean, if you take a look at it, he he first says that the condition that is no is right, like what we said. First, this condition is no. If the first one and last one are 1, or the value that's the index that has value 1, and or the value that has the index that has the value n is 1, these are the cases that are not possible. This is okay, right? This is okay. We already discussed that. If the first one or last one are 1, or 1 and n are 1, the first one and the last one are 1, it's impossible. Otherwise, he says that let's consider 1 and index of 1. It means that let's consider the position 1 and the position that has value 1. So 1 has A1. We consider index of 1 the place that has value 1. And then let's consider index of 1 and n, which has value an. So it turns some of them into 1. Which ones turn into 1 this way? Everything that is from 1 to index of 1 and are between 1 and A1. Yeah, that's great. Everything that is in here as in and is in the range from 1 to A1 turns into 1 by doing this. And everything that is in here that is in the range from 1 to an also turns into 1. And then he says that let's do 1 and index of n and index of n and n. So I consider index of n the position that I have n and index of n. And do it with the first position and the last position. Again, by doing this, everything that is in here as and is in the range from A1 to n turns into 1, and everything that is in here and is in the range from an to n turns into 1 as well. And then at the end, he says that let's do these two indices. By doing so, everything that is in this range, in the middle, and is between 1 to n will turn into 1. So if you do that, guys, actually, you can easily see that everything that is in here turns into 1. Because everything that is in here is either in the range from 1 to A1, or it's in the range from A1 to n. Right? Because it's between 1 and n, and it's not A1. A1 is already here. So everything in here turns into 1. Also, everything in here turns into 1, because everything in here is either in the range from 1 to an, or in the range from an to n. So everything in here turns to 1 as well. And then everything in here turns to 1 as well, because this is 1, this is n, and everything is between 1 and n. So everyone in here turns into 1 as well. So this way we turn everything other than the first and last index and the indices with values 1 and n into 1. These are the maximum things that you can turn into 1. So everything else is, we said that these values cannot be 1, and then we had a solution that turns everything else into 1. And this way we can solve the problem. This was a very better solution that actually used the fact that we have 5. Because the thing that we were saying was not actually using the thing that it was 5. So that was a bit suspicious as well. I don't think it's unrated. Is it clear now? Largest right-mode index. Yes, I agree with your doubts. Yeah, I mean, I that's completely fair. Do you have any questions you can do before this? Um, there are some questions that we have some operations, fixed number of operations that we should work on. I mean, we should construct a solution. I mean, you can search with problems with tag constructive. But I hope that I can, at least at the end, after we spend much time, make sure that all of you understood it. Because the solution was actually really beautiful. If it's clear, please put a plus or use this emoji. If it's not, put a minus. Yes, quite tricky. Nice, Kriya. Awesome. Yes. Now, and guys, thank you so much for. I mean, this was a great discussion, actually. I mean, the issue that you raised, really proud of you. You can understand the things that are problematic. That's really great. We are on problem B and we solved it. Finally, we actually discussed a solution at the first, but it was problematic. And if we wanted to fix that problem, it would be way more complex. I mean, if we would fix it, then we could solve it at what is the minimum number of operations to solve the whole thing. So we would solve a harder problem afterwards. Salam be. Oh, come with this. How to come with this approach? You have to solve a lot of problems, actually. I mean, it's a I mean, if you want, you can open Codeforces, go to problem set, and search for problems with tag constructive. This problem was a constructive problem. I mean, I don't know if the tags are there already or not. It's only maths here so far. But this is actually constructive. We are constructing a solution that has Atmos 5, for example, in here, Atmos 5 operations. You can search for constructive problems, and then there are a lot of problems that might. I don't think we had a topic stream on constructive problems when we have to construct the solution. If you want, we can maybe work more on that in the next boot camps, or we can choose the best problems and discuss them. If you like this type of problems, somewhat clear. Awesome. If you had any hesitations, definitely let me know. I mean, I want to make sure that it's clear for you guys. If it's fully clear, shall we move on to the next problem? We like everything math related. Awesome. And guys, what do you want to be the next bootcamp about? I know that this problem was very complex. Let's do a 2-3 minutes discussion and then move on. Our expert bootcamp, I think it has only 2 sessions left, either 2 or 3. From the beginning, I said we have either 5 or 6 days for the camp. Maybe we can set it for 6 days. And then you can choose what you want in the next bootcamp to be covered. Let me know about this. I guess in constructive problems, constructing a suspect is a way many times. Yes, constructing a supersets. Yeah, you are supersets. Yeah. Actually, for this problem gave that vibe, actually, because it says that these ones should turn into 1 and zeros are not important. So it's shouting to you that it's, let me pause this. It's shouting to you that it's, you just need to find a superset. Yeah, I mean, that's a very good thing that it feels like this. Bro, I had rank of 2K currently. Yeah, you should see. I don't know how much I think. I don't know if these extensions that predict rating still are working or not. I hate constructive problems, and I will do it more from now. Yeah, if you want, yeah, uh we can do constructive solutions. I mean, we can have either a topic stream or a bootcamp. A deep solution for this problem that is solved, problem B. I don't think so for problem B. Expected rate of problem B. I don't think many people have solved it because most of you guys said that you didn't solve this problem. So, but the contest was for 2 hours. So probably something like 1500s, 1400s. I don't know. What do you guys think? Maybe something like that. And guys, if you want to be in a team to learn something together, make sure to take a look at this teams section in the website. It's great that I see some of you are creating these teams. This team actually has 12 members. 12 members are now in the team to reach pupil. That's actually very interesting. So if you want anything to do and you don't have access to other people that want to learn CP, that's it most important needs. So I was like, I always try to think about all the ideas that might help to fill the gaps that are there. We are really aiming to build something amazing, something that would be really, really helpful. And this was an idea that came to my mind that would be super important for the pain that many people don't have other people to learn with. And actually, when more than one person, together people work on something, they can push each other and they can learn way better. So if you want to learn anything, you can just create a team here and say that what you want to learn and describe it, say that what is its level, you want it to be open to everyone, or you want people to request and you approve it, and put a Discord link. And then and then you guys can continue doing it together. You get familiar with many others that want to learn things like you. You can do, for example, you can say that I want to do a virtual contest. I want to reach experts till in 2 months. I want to become a red scholar or in 10 days. So that's impossible. I mean, but I want to become a red scholar in 6 months, for example, or some things like this. You can say that and other people can join you. I created a team myself as well, build and learn with RepoVive, that if you want to do these interesting things, we are very ambitious to do amazing things. And if you are also interested and you're really ambitious, you can also request. I approved all the requests that came to us. So we have 28 people now. I don't know if you have any requests. Why I sent requests to join myself? Why it lets me send requests to join? It was my other email. So we have another 12 join requests now as well. So we get to 40 people. That you can, if you want, you will join the level 0 and we can do some small things together, and then you can be promoted from there and go to level 1, level 2, etc. And we can do more and more things together. So if you want, you can do it. Nice idea. Great. Yeah, I mean, all the ideas are not should be on solving problems, CP problems. Sometimes you should do other things. If you want, if you are into it, and if you also feel like it would be something that would help you and something that really would be amazing for you, definitely go. And that's something that I deeply suggest to you. I said it yesterday in the camp that one of the reasons that I was not going to gym very well just a few months ago. Now I have a lot of books and I can't go to gym anymore. I mean, I don't have the time. But before that was that I lost my gym buddy. The person who was coming to gym with me, he couldn't come anymore. And then I alone didn't have enough motivation to. Sometimes I was tired and I was like, okay, forget about it. When you have more than one person and you do it together, it's way better. And I think that solves a very important pain point for you guys who are who are trying to learn competitive programming but don't have people. For example, in your school, there are not other people who are learning competitive programming. That's great. I mean, if you want to reach specialist in 2 months, you can just write it in here and other people can join you. I see that the number of members is growing. It's great. It's great that I'm introducing this to you and more people can actually benefit from it and use it. Okay. I think we can now move on to problem C if you are ready. What is the meaning of repo wife? Do you know what repo is? Repository? Code repository? We will explain it. The bootcamp will be for 6 sessions. We have done 3. We have done half of it, and the videos are all here. If you come to bootcamps in RepoVive, if you open this, you can just join this and see the videos. The third video is not here for some reason. It should automatically fetch it. But anyway, for now, I should add it manually. And then all the problems are here as well. And discussion is here as well. So, guys, sorry that I haven't answered your questions yet. I saw it yesterday, but it was because the camp continued till 1:30 a.m., I think, yesterday. So I went home after that. But I will answer all your questions. And tonight, tomorrow morning, tomorrow morning for most of you is going to be the next session of bootcamp. We can go to C now. Shall we move on to C? Are you guys ready? Let's move on to problem C now. Problem C. Problem C, I read this very quickly as well. Let's discuss the solution. It says that you are given a grid A of 2 rows and n columns where every cell has value from 1 to 2n. Let f of L and R be that, in our grids, everywhere that our value is between L and R will be 1, everywhere else will be 0. And you have to count the number of pairs like L and R such that in f of L and R, there exists a downright path of adjacent cells with value 1 from cell 1, 1 to 2. Okay, guys, what is the first thing that comes to your mind when you read this? For myself, when I read this, I say that for a specific L, let me know, correct me if anywhere I'm wrong. Because I'm also someone who saw the problem and I can make mistakes too. But when I read the problem, the first thing that comes to my mind is that for some fixed L, if some R works, then any R greater than that works as well. Right? Do you guys agree with this? You're very happy. Do you agree with that? When some R works, any R greater than that works as well. Do you agree? And for each R, if some L works, any L less than that works too, in the same way. It either can give you the feeling of binary search, which is right. For each L, we can binary search for R, or also two-pointer. For me, it first brings me to the idea of two-pointer. I didn't think enough about it, but first of all, it tells me that, okay, this looks like two-pointer. For each L, we have another pointer R that as long as it's not still working, we'll move R forward. And when it works, we add n minus R and then we move L forward 1. So we should just have these operations to change something from 0 to 1 or from 1 to 0. And after that, can easily check that if there's a path from 1 and 1 to 2 and n. Okay. That's the first thing. I'm thinking about the rest right now because I just raised once in a minute before starting a stream. If you have anything, guys, you participate in the discussion as well. If you have a solution for it, definitely let me know. But what I'm thinking right now is that I'm thinking online. is that actually any one that you have, I mean, our path will be like this. We will have a prefix of the first row and the suffix of the second row, right? So we should always have the maximum prefix in the first row and the maximum suffix in the second row such that they're all one, okay? And how can we have this? We can have a set. We can have a set of all the zeros in the first row and all the zeros in the second row. All the positions in the first row that are zero, I'm just thinking online, guys. If any part you feel is problematic, let me know. We can see all the zeros in the first row and all the zeros in the second row and have it in a set. And then in order to find the maximum prefix in the first row that are all one, you can just see that, okay, what is the minimum index zero in the first row? And to find the maximum suffix in the second row that are all one, so you can say that, okay, what is the maximum index that is zero, maximum index that is zero in the second row? And if the sum of the length of this prefix and the suffix was at least n plus one, the answer, I mean, it means that we have a pass, downright pass, otherwise we don't. Why? Because if it's at least n plus one, it means that this prefix and these two suffix touch each other at some column. And if they touch each other at some column, we can go till here and then go down and go from here. So that's what I think we can do. Do you guys agree with this? Two-pointer is a good thing compared to binary search, and that is that you can update things one by one. So what do I mean? In two-pointer, you each time either add one to L or add one to R, right? I mean, these are the operations we have. Adding one to R means that turning a zero into one. Adding one to L, it means turning a one into zero because something was in your range, but it's not in your range anymore. You can do both of the operations easily with the sets. You have a set. So adding a zero, it means inserting something to your sets. Adding a one, it means erasing something from your sets. So each time you add one to L or to R, and you can update your sets and easily get these values. Do you think how do you feel about this solution? I will go over it once again. Let me first see that if you guys have used the same solution or something else. Has anyone accepted it with this solution? Or anyone has any simpler solutions? And if you guys understood it and agree with it or not. If you understood it and agree with it, please put a plus. If you didn't understand it or if you have any doubts or anything, put a minus. I want to just see that what do you guys think? Yeah, you can use this emoji as well if you want. I will go through the approach once again. Great, awesome. That's great to hear. If you were part of the camp, we would celebrate it right now because, I mean, that's actually something that I want to ask anyone in the camp. That how is the rating changing? But I'm not sure if you were in the camp or not. If you were in the camp, we would celebrate. Anyway, so let me tell you about this again. So actually, what do we have in here? I'm gonna use a two-pointer approach. Let's consider an example. Okay, we have these values. Each of them are from 1 to 2n. Let's consider, for example, this case. And L and R should be from 1 to 2n, as mentioned. Because in this example, we have a 2 by 3 row. I'm talking about this example. And the values are 1, 2, 3, 3, 2, 1. At the beginning, let's set L equal to 1, R equal to 1 as well. And guys, intervals are inclusive, exclusive. So L equal to 1, R equal to 1, it means that it has nothing. It's empty. So everyone will be 0. Do we have a path from top left to bottom right? We don't. So we should add 1 to R. R turns into 2. R turns into 2. It means that now we have all the ones. First, we add this one. So now what is the maximum prefix in the first row that is 1? Is 1. And this 0 turns into 1 as well. Now what is the maximum suffix in the second row that is 1? Is 1. Do we have a path from top left to bottom right? No, still don't. And then we add the 2's. I mean, we add 1 to R. We have to again add 1 to R. So R becomes 3. This will turn into 1. This will turn into 1. Now the prefix that in the first row that has 1s is 2. The suffix in the second row that has 1s is 2 as well. Do we have a path from top left to bottom right? Now we have. Now because this prefix and this suffix touch each other, they overlap. If the sum of the length of the prefix and the suffix is at least n plus 1, it means that they will touch each other. So there is a path, actually. And so it's okay. So R equal to 3 works. So we should add 2n minus 3 plus 1 to our solution, which is 4 choices. 1 and 3 works, 1 and 4 works, 1 and 5 works, 1 and 6 works as well. So now we add 1 to L. L turns into 2. And then when it turns into 2, these ones turn into 0. Do we have a path from top left to bottom right? Again, we don't. So we keep continuing adding and removing numbers. I mean, moving L and R. And this way we find out if they have a path from top left to bottom right each time. How? But each time we try to keep the maximum prefix in the top row and the maximum suffix in the second row. And we see that if they touch each other or not. No, it's off 2n. Because in a two-pointer approach, each time we are either moving L forward or we are moving R forward. We are not checking it for each L and R. Okay, so it's 2n, so it's going to be of n log n because we have a set to. We have a set to keep that which are the indices which are 0. Which indices are 0. And the minimum index in the first row that is 0 means that shows us the length of the prefix that is 1 in the first row, and the maximum the maximum index in the second row that is 1, that is 0, shows us the maximum suffix in the second row that is 1. Is it clear or not? The problem can be summarized to find. The problem can be summarized to, for each L, find the minimum R that works for it. And that's what we are solving with 2 pointers. If it's clear, please put a plus or use the emoji. Use this emoji. If it's not, let me know. Well, we need to know that what is the length of the maximum prefix in the first row that they are all 1, right? And we need to find the maximum length of a suffix in the second row that are all 1. What does maximum prefix they are all 1 mean? It means that the next element is the first 0. So if we keep a set of all the positions of 0, the first position 0 shows us what is the length of that prefix that we are looking for. I will show you this implementation. I think that I will explain it on an implementation. I think that I will make sure to make it crystal clear by that. Is it clear? Let us take a look at people's solution as well. See that if they've done the same thing or not. Uh, let's take a look at what this guy has done. He says that for I less than n plus n, who writes n plus n? That's interesting. I plus plus pi equal to n plus n plus 1 s dot inserts b of I uh s dot inserts a of I l equal to s dot begin r equal to s dot r begin pl equal to minimum of phi of l and r. Okay, first of all, this part is where he is adding that he says that for each I, the minimum index that we should have on the other side is minimum of k and pi, which k is the minimum of everything that we had before it. I mean, after it's for values greater than it. And L equal to this. Okay. Okay, I see what he's talking about. Okay. He has a different solution that I will talk about it too. Uh, so he actually says that we should have a path from top left to bottom right? What does a path that goes from top left to bottom right look like? I mean, guys, I want to explain this to you as well, but I know that you might want to see a solution of the thing that we discussed as well, or do we have that or not as well? Let me take a look at the other solutions as well. I want to explain also to you what this guy has done. That's also an interesting solution. He in here uses priority queue instead. Let's see what Jiangli did. He also says that, okay, for each I, he finds fi, that fi is the minimum index that we have for that. Let me tell you that, no, updating a set is off login. Updating a set is off login. Let me tell you that what this guy has done. Well, in here, he says that what does a path, how does a path from top left to bottom right looks like? We go right till some points, and then at some point we go down, and then we continue going right. All the paths look like this. A path that goes from top left to bottom right is like this, right? He is trying to fix that. Where is that position that we go down from? I mean, he tries to consider this column. He talks about this column and wants to see that, okay, if from this column we want to go down, how would it look like? Initially, he assumes that we will go down from the first column. From the first column, we will go down and we go right. If that's the case, we should choose a value, choose some L and R, such that it will include all BIs and also includes A of 1. So for that, we should cover A of 1 and we should cover all the BIs, right? So that's why he first inserts everything to a set named BI. Set a set named S. He inserts all of BIs in S. And then in his for, he each time first adds this AI, So first, I mean, right now at the first position, we have A of 1 and all of the B's. We have A of 1 and all of the B's. And then for that, he says that, okay, how should be L? How should be R such that all of these will be covered? L should be at least S dot begin, R should be at least S dot R begin, or the rightmost. We have a set. I mean, if we consider all the BIs and only A1, we have a set. Our L and R should be in a way that they will cover all of these values. So what he says is that, okay, if we want to cover all these values, if our L is this much and R is this much, it will cover all these values and we are going to have a path from top left to bottom right. So it says that P of L mean equal to P of L mean equal to R. Why? Because if our L is this, our this R would work for it because we have this path. And then each time he will erase the current BI, and instead of that, next time he adds the next AI. It's like next time he's considering this path instead. And then again next time he will consider this path. He will erase this BI and insert this AI instead. Each time this this BI will be erased, this AI will be inserted. So this way, all of the paths will be considered, and for each path, we're gonna come up with an L and R, and we say that, okay, if we can cover everything in this range, it will work. And then it's just enough to find out for each L what is the minimum value R that we can have that all of this will be covered. And that's gonna be all. I hope that this solution is also clear. Please let me know if the solution is clear or if it is not. I hope that I haven't lost you guys. I know that it got a bit challenging. Don't hesitate to tell me if there are any doubts about it. I know that it was a bit overwhelming or challenging. I would be proud if you understand it, if you understood it. But if you didn't fully understood it, it's completely okay. Let me know. I mean, don't hesitate to tell me. I'm in an area of pairs representing me myself ever. But wouldn't there be repeats? Yeah, I mean, we're not counting the number of paths. We are just saying that if I cover all these values of L and R, I mean, if all these, I mean, each time we have a set and we know that if everything in this set is covered, then we have a path from top left to bottom right, right? Each time we are just saying that, okay, so for this specific L, this R works. So we say that P of L mean equal to R. For this specific L, this R works. P of L, so if our L is this, P of L says that, P of I says that if our L is I, what is the minimum R that we can have? Now we figure out that, okay, for this specific L, even this R works. So if P of L was more than that, we turn it into R. And then we update P of i's and we start from the end. And for each element, it's like in here, it's like we are saying that P of I mean equal to P of I plus 1. Because if L is equal to I plus 1 and some R works, that R works for I as well. That's why each time he's calculating this cumulative minimum. And when he gets to each point, he's updating that value. And then he says that each time rest plus equal to 2n minus k plus 1. So for each L, this way he can find out the minimum value of R. And he will calculate a cumulative minimum from the end. I know that, again, it might be a bit challenging, but let me know if you have an issue. It depends on what was the rest of your solution. Do you meditate? That was a very good question in the middle of solution discussion. Why? I do not, unfortunately. Assuming I will list of mean max pairs for all pairs. The unique number of LR I do not understand completely what you say. Are you defining another problem, or is it a question about this solution? This is a good visualization approach, and could you just go over it again? Okay, yes. Well, the point is that if for each L you find the minimum value of R, if for each L you find the minimum value of R, then you have the number of answers, because each time you can say that, okay, my L is this, what is, and you know the minimum value of R. Any R more than that would work as well. So then you can simply find the solution this way. Any R greater than that would work as well. So you can just add 2 and minus that R plus 1. And as I said, each time he's considering all the possible paths. And for each path, he will consider that he will keep in his set what are all the values that appear in this path. And then he should choose a L and an R that L is less than or equal to minimum of these values, and R should be greater than or equal to maximum of these values, so that all of these values will be covered. So what should we say? What does this mean? It means that P of L, the minimum value that R should have for a specific L, you should actually say that P of L mean equal to R, because now for this specific L, this R works as well. So any R greater than or equal to this would work as well. So this way, for each L, you will find the minimum R, and then at the end, you can go over all of the indices. Each time say K mean equal to PI, and then add that to the rest. I hope that it's clear. We do not eliminate repeats. We are not counting the number of paths. What do you mean by eliminating repeats? It's okay to have repeats. I mean, we're not counting the number of ways. That's for when we are counting the number of ways that we eliminate the repeats. I mean, in here, we have just conditions. If one of them are satisfied, it's okay. So for each L, we calculate the minimum possible value for R. Yes. The part of his code that is calculating the number of ways is this. P of I means that if L is equal to I, what is the minimum value for R? P of I says that if L is equal to I, what is the minimum value for R? So actually at the end, if I have a better implementation than this, that is more clear to understand what is happening, you can simply say that P of I should mean equal to P of I plus 1. Because whatever P of I plus 1 is, P of I can be that too. Because if something works from I plus 1 to R for some R, then I to R works as well. Therefore, at the end, you can just say that P of I mean equal to P of I plus 1. In here, he just has this K that says that, okay, what is the minimum value of R that works for this specific L, which is I. And then you say that rest plus equal to 2 and plus 1 minus that. And at the end, it will output source. I think it's very good if we solve problem D as well. And I should make sure that we do go more quickly. If you have any question, I hope that it was clear. If by any case was not clear, you can also ask me questions in blog. Let me create a blog very quickly so that you can ask your additional questions there, and I can answer your questions there. Discussion of CF round 1063. Ask your questions about this round. So if anything was not clear, you can definitely ask me in here, and I will try to respond. I will respond to all of your questions. I will definitely respond to all of your questions. I created the block. I'm doing it so that we can make sure. I really hope that it's completely clear for everyone. But in case, if at the end, for example, even when you are implementing them or anything, you feel like something is not clear, I want to give you an opportunity to still ask that. And guys, I want this community to get, more engaging and etc. so that it would be actually helpful. If you can answer each other's question, that would be great too. The real discussions can happen again there, and you might get to know each other there, and that would be very good if that happens. And I will also answer your questions there after this. Yeah, yeah, that's okay. I mean, that happens. The key point is that you won't get disappointed. I didn't see your question. I think is it for problem B how to calculate the leftness. Uh, guys, we talked about another question, another solution after that for problem B. That solution had an issue that you guys pointed out, and that was completely correct. That solution had an issue. So after that, we showed another solution for that problem, which we just solve it for for five operations. What will be difficulty of repo wife contest? It would be similar to diff 2 rounds of CF, similar to that. From your experience, how to solve how to problem setters come up with such complex problems? They think a lot. That's actually what happens. Guys, let's move on to problem D very quickly as well. If you had any questions, again, feel free to ask it in this blog. I don't know if any questions are there already or not. There's not. Feel free to ask your questions there and I will answer it there. I will receive an email when you ask questions in the blog. In the camp, still it's not there, but I will add it. But in there we have it. Finally, okay. Let's move on to problem D as well. I haven't read problem D. I hope that it's a short statement. Oh, we don't have D. We have D1, D2. This is the easy version of the problem. The difference between the versions is that in this version. You can make at most 30 queries. Okay, the only difference is that in this one you can make 30 queries. Okay, so let's talk about this D2. The problem is interactive. There is a permutation P of integers from 0 to n minus 1 hidden from you. Additionally, you are given Q ranges, where Li and Ri are from 1 to n. You need to discover the minimum mix among the values of, from 0 to n minus 1. Minimum mix among the values of P in the Q ranges that are given to you. Okay, you have to find that what is the minimum mix you get. Well, you must discover value of maximum possible, maximum mix. Maximum of mix of PL to PR. I just received an email that we have a comments on there, on here. This is working good. So anyway. To do this, you may take at most 30 queries of the following. For choose any two integers L, R from 1 to n, and you will receive the value of mix of PL to PR. Okay, so you need to find out the maximum mix that we can have in the range, in the ranges that are given to you. Among all of them, you need to find the maximum one. Okay, interesting. That the statement as it looks good. Let's take a look at this solution now. Yeah, I have a lot of DP streams. Most people say that why every time because most of the times you guys vote for DP. So yeah, there are a lot of DP streams. You can easily find them in the YouTube channel. That's the last. Well, and there was a two-way communication problems. Oh, that's interesting. I probably we don't get to that problem, unfortunately. If we would go a bit faster, we could go over that too. That's a long solution. Let's see if there are any shorter solutions. So guys, we have several ranges. We want to find the maximum possible mix that we have among all these ranges. Each time we can ask for the mix of a range, a subarray. So what do we say? Let's see what this solution is talking about. He gets N and M, and then all the L and R's. You get N and M and L and R's. And you know that the array has values from 0 to N minus 1. He says I and j, R of I min is equal to max of R of I and j. So first of all, he says that, okay, for each I, it's just enough to keep that what is the maximum j that we have. Because if you have two ranges that both of them start from the same place, the one that goes more to the right is better, definitely. And then he says that if Ri is greater than k, q dot pushback Ri and Ri. Let me first understand it and then I'll explain it. If R of I greater than k, q dot pushback. Okay, yes. So again, he's trying to get rid of the useless ranges first. So all the ranges are not useful and they are, if L of something is more than R of it, L of the next one is more than R of that as well. And then, if L of something is less than the L of the other one, so far R of it is less than the R of the other one as well. Then he does a binary search, it seems. L1 and R1 equal to Q of MD. Do we have a permutation? Okay, we have a permutation, so yeah, makes sense. Okay. So we have only a 0 in one place. That's very important. Each time he takes the middle point and then he says out of L and R. Okay, he has L1, R1. Ask 1 and R1. Yes. Oh, I really like the solution. I really like the solution. Okay. So guys, let me tell you the solution. Yes, it's a binary search. Let's go over this problem again. Let me quickly tell you the statement again. The statement says that there is a permutation P. It's a permutation. from 0 to n minus 1. I read it several times, but I don't know why I forget it's a permutation. Additionally, you are given Q ranges, L1 R1, L2 R2 to LQ RQ. And you need to discover the maximum mix among all values of P in the Q ranges that are given to you in the input. Formally, you must discover the value of maximum of the mix from P of Li to P of Ri. To do this, you might take at most 30 queries of this form. Each time you can ask a range for this mix. Guys, first of all, if we have several ranges if we have two ranges that both of them start from the same place, then definitely this range is useless and it's not our answer. We can easily remove it. So for each I, we can take the maximum Ri that it has. And then if we have two ranges such that one of them is completely inside the other one, that's also useless. We remove that too. So we can start from the beginning. We can do similar to what this code did. Take a look at this. We can take the Ri's and then have a for each element. If R of I was greater than K, I will say Q dot pushback I and Ri. Otherwise, I will skip it. So I keep that so far. What was the maximum Ri? If it was greater than that, I will push it into Q, or I will ignore it. So then I will come up with some ranges that look like this. I'll come up with some ranges that look like this. If something starts after the other one, it ends after the other one as well. Our ranges are all like this. Now, the point that we have is that this is a permutation. So we have only one specific zero. This is a permutation, so we have only one specific zero. So what we can do is this. We can each time take one of them. Let's take the middle one. Consider this one. For example, this is the middle one. Take a look at this and see what is the mix from the starting point to Ri. And then take a look at what is the mix from the starting point to Li, or to Li minus 1. And see that if it changes, the mix changes. Or no, it's better if we do this. From 1 to R, and then from L to R. We know that this range, this bigger range, this prefix is better than or equal to, is at least as good. But the question is if their mixes are equal or non-equal. Okay. If the mixes, first of all, whatever we get in here is one of the answers. So we can say ans max equal to whatever we have in here. And then we can say that if the mix of this larger range is greater than what we have in here, it means that if the mix of this is x, the value of x itself is to the left. So if we want something better than x, we should go for the range in the left. Otherwise, if it's equal, it means that there's nothing valuable to the left. Even if we take all of them too, none of them add anything. So we can discard all of these ranges and simply go to the right. And therefore, we can easily find out each time if we need to go to the left or to the right. And that would help us find the range that gives us the best answer. And this way, we can get our final answer. Is this clear? I really like this problem. It was a really beautiful problem. Some interactive problems are really beautiful. It's not really that important for this problem. If you have previous problems not accepted yet, focus on them first, because this can be a bit distracting. But okay, if you almost understood, I explain it again, because it's really great if you understand it well. What do we say? See, we have several ranges. I first say that for the ranges, if one range is completely inside another range, that's useless. That range inside is useless. That's definitely not the answer because another range is a superset of this range. Otherwise, our ranges look like this. I say that consider the middle range and see that what is its max. Assume that it's x. Then consider the max of the range from the beginning to the right of this range. And see that what is the max of that. If the max of that was greater than x, it means that the value x itself is to the left of this point. So we should, if we want something better than x, definitely we should search in the ranges in the left. Otherwise, it means that left has nothing valuable for us. Even if we have all of them, our max is going to be the same. So we should go search to the right. So each time we take the middle one, we say as max equal to this, and then we either go to the left ones or to the right ones. This way it will take off log, and each time we are asking two questions, which would in fact give us exactly, that at most 30 operations, because n is up to 10 to the fourth. Is it clear? Great. Hello. Is it clear, Parth? Or do you need more explanation? Feel free to tell me if anything is not completely clear. Awesome, awesome, awesome. Great. So this is also problem B. And as I said, guys, if you had any questions, you can ask in this statement, in this block. What am I saying? My mind is not working anymore. After having so many streams, I'm losing the abilities of my mind. So you can ask it here, any questions you might have. If you can also answer each other's question, it would be great as well. See you guys hopefully in the fourth session of our bootcamp. Might unite most of you tomorrow morning. What will be next bootcamp on? You will say. I'll vote. I will put a vote. Greater intuition, I'm not just able to notify ranges for greater than. Well, mix is the smallest number that is not in a range. So if to the left our mix has not changed, it means that it has nothing valuable for us. We should go to the right. If to the left our answer is better than x, it means x itself is to the left. So if we want something better than x, we want our mix better than x, we should go to the left. Sure thing. I really hope that it was helpful. I really liked problem D. That was the best problem. I liked B too. It was a bit hard for problem B, but its solution was cool. I liked it. C was also good as well. I liked C too. This was, in general, it was a hard contest, but it had good solution. If all the problems were shifted by one, it was better. Okay. Yeah. Okay. Should we do DP for experts? Yeah, you can suggest. You can suggest anything and I'll put a vote on them. Okay. So see you guys soon, and don't forget to participate in the first Repo Vibes contest. And I hope that we can do many, many great things together. Thank you, guys. Yeah, A was not bad. Yeah, A was also interesting. See you guys next time. Bye.